In the next 3 units, we're going to take a look at perimeter and area. And in your textbook, these are units 19, 21, and 22. And so I'd like to focus on 3 different shapes: triangles, quadrilaterals, and circles. What do we do with these measurements? Well, we use them to find perimeters, areas, and in some cases, if we go 3-dimensional, volumes and surface areas. And so let's just focus right now on the 2-dimensional aspects, which are perimeter and area. Perimeter is the total distance around an object or a shape, and so the sum of all of its side lengths. The area is the amount of space the 2-dimensional space occupies. For example, with triangles, you've probably seen the formula that area equals 1/2 base times height, or some people might refer to it as base times height over 2. And this is a very well-known formula. You have probably used it many times yourself. And there's one main thing I want to make clear in it, and that is, in the formula, the sides that you refer to as base and height must be perpendicular to each other. So in this triangle, the base is the bottom side and the height is the red line drawn that is perpendicular to it. Multiplying 1/2 the base times the height would give us the area of this triangle. The sum of all 3 sides, side 1 plus side 2 plus side 3, gives us the perimeter. So P is our short form for perimeter. Another way to find the area of a triangle is by using what is called Hero's formula. And this is used when we don't know a height. If we know the 3 sides of a triangle and it's not possible to find the height, then you can find the area of a triangle using Hero's formula. So Hero's formula involves the 3 sides A, B, and C, and one other value that we refer to as lowercase s. Before you use the formula for area, for Hero's formula, you have to calculate s. S is equal to the sum of the 3 sides, A plus B plus C, all divided by 2. And then that number is subbed in under the square root sign here, and then in the brackets you subtract one side from it, and then in the next set of brackets you subtract the second side from it, and in the third set of brackets you subtract the third side from it. Once you get these 4 numbers, you multiply the 4 together, you'll get a product, and then you do the square root. That's how you use Hero's formula. Next, we will take a look at quadrilaterals, 4-sided figures. And so the first 2 you can see on the screen here are the square and the rectangle. Both of these have right angles in all 4 corners of the figure. And so right angles in all 4 corners. For a square, if we call side length lowercase s, and you can call it anything you want, in this formula it's s, then the area will be s times itself, s times s, which is s squared. And the perimeter is 4 times s. For a rectangle with a length and a width, the area is length times width. And the perimeter is 2 times the length, because there are 2, one here, and 2 times the width, or 2 times the length plus the width. We can also take a look at parallelograms. A parallelogram is another quadrilateral that has 2 sets of parallel sides. One set of parallel sides are there and there, and the other set of parallel sides are here and here. And it's very similar to triangles in that the base and height must be perpendicular to each other, as I have drawn right here. So the height is the perpendicular distance between the 2 parallel bases. And when multiplied by the base length, you get the area of the parallelogram. The perimeter is 2 times the slant heights, A, plus 2 times the bases, or 2 multiplied by A plus B. A rhombus is kind of a special parallelogram in which all 4 sides have equal length, and therefore the height, the perpendicular distance between parallel sides, is a little bit less, but it is still the height of the figure. So in this case, the area is S, which is actually its base, times height. And the perimeter is 4 times S. One more quadrilateral to have a look at is called the trapezoid. A trapezoid has one set of parallel sides, and the other 2 sides are not parallel. The height is the same as it is in a parallelogram and a rhombus. It is the perpendicular distance between the 2 bases. And in a trapezoid, these will be different lengths, so they're B1 and B2. The area of a trapezoid is 1/2 the height multiplied by the sum of B1 plus B2. In a sense, we take the average 1/2 of B1 plus B2. You take the average of the base and you multiply by height. So it's another way to rearrange it. But that's where the formula comes from. And the perimeter is the sum of all 4 sides. Let's now move to circles. The perimeter of a circle has a special name called the circumference. It is the distance around the outside of the circle. And 2 different lines inside the circle. The line from the center of the circle to the outside of the circle is called the radius, with R. And a line that is twice as long as R, that actually goes from one side of the circle through the center to the other side directly, is a diameter. Diameter is 2 times the radius. And so the circumference is 2 pi r, or pi times d. The area is pi r squared. Now let's take a look at some examples. I talked about Hero's formula a little bit earlier, and you probably haven't seen that one before. So let's take a look at an example to find the area of a triangle when the 3 side lengths are given in meters. So we might call this side A, side B, side B, and side C. But it doesn't really matter how you name them. So remember, Hero's formula was area equals the square root of S times S minus A times S minus B times S minus C. Before we do that, we must calculate S, which is A plus B plus C over 2. So that will be 187 plus 206 plus 293, all divided by 2. And let's see with the calculator. So 187 plus 206 plus 293. And that's the numerator. We want to get that full sum. So I should hit equals. 686 divided by 2, which is, and we will divide by 2 now, 343. All right, now when we use Hero's formula, I'll just give myself a little extra room here. Area is the square root of 343 and in brackets 343 minus A, which is 187. And the second one is 343 minus B, which is 206. And the third one is 343 minus 293. Okay. Under the square root sign. $343 multiplied by, well, 343 minus 187 is 156. And 343 minus 206 equals 137. And the last one is 343 minus 293, which is 50. Okay, now we need to multiply these four numbers together before we take the square root. The area is equal to the square root of, what's this big number? 50. I've already got it in the calculator, so 50 times 343 times 156 times 137. All right, 366, 529, 800. 366, 529, 800. And we should now square root that. So on the calculator, I hit the square root button, which is here, and hit equals. 19,140, let's say 145. 19,145, and that was in meters, area which is squared. Okay, we do get meters squared because this would be meters times meters times meters times meters, which would be meters to the 4, and when you square root meters to the 4, you get meters squared. So that's an example of Hero's formula. Moving on to quadrilaterals, find the area and perimeter of the rectangle shown. Well, area is length times width, which is 6 centimeters multiplied by 3 centimeters, which is 18 centimeters squared. The perimeter is 2 times the length plus 2 times the width, which is 2 times 6 centimeters plus 2 times 3 centimeters, which is 12 centimeters plus 6 centimeters, which is 18 centimeters. I did not intend for those to be the same number. That is purely a coincidence. Let's find the area of this parallelogram and the perimeter. The area is equal to base times height. The height is given at 10 millimeters, and the base is the side that is perpendicular to that height, which in this case is 22. So we have 22 millimeters multiplied by 10 millimeters, which is 220 millimeters squared. The perimeter is equal to 2 times the bases plus 2 times the sides, which I think in the formula we call them A, right? So 2 times the 22 plus 2 times the 13s. So that gets us 44, and I kept the units out, but that would be millimeters, and 26 millimeters. And when we add those two together, 70 millimeters. Sounds like I got a little disagreement from Simba over there, but anyway, I don't think he knows how to calculate these things. Okay, working on the area of a trapezoid. And so a trapezoid has two sets of parallel sides. The area is given by the formula 1/2 times the height, and we must add the parallel bases together. So that is 3 meters. Let's write the formula first. Base 1 plus base 2. And the numbers we're putting in are 1/2 times 5 meters multiplied by 3 meters plus 9 meters. And that is 1/2 times 5 meters times 12 meters. And when we multiply all of those together, okay, let's see, 30 meters squared. 1/2 times 5 times 12. One thing I like to do is, I got an even here, which is 12, so half of 12 is 6, and then I just multiply by 5. So that was one way to do it in your head. You can also do this one first too, and then as long as you get the sum inside the brackets before you multiply, then everything should be fine. And now I'm going to give you a chance to find the area of the figure shown. So a big part of this is recognizing what figures you have. I've shown parallel sides, so we have parallel sides here, and I think it's also important to indicate the right angles in there, just so it's not assumed. But so we have a rectangle on top of a trapezoid. And find the area of this figure. Pause the video, and when you turn it back on, I will take it up. Okay, so for area total, that is equal to area 1 plus area 2. This will be what we call area 1, this will be 2, which is equal to length times width plus, for the trapezoid, 1/2 height, B1 plus B2. All right, length times width, that's 11 centimeters times 4 centimeters plus 1/2. The height's 12 centimeters of the trapezoid multiplied by 11 centimeters plus 28.8. I'm just going to leave the units out of there because of the space. Okay. What have we got here? 11 times 4, 44 centimeters squared plus 1/2 of 12. Let's call that 6 centimeters. And in brackets, we have to do 11 plus 28.8. That will be 39.8 centimeters. And now 44 centimeters squared plus 6 times 39.8. I'm going to grab the calculator for that one. 6 times 39.8 equals 238.8. 238.8 centimeters squared. And when we add 44 to it, plus 44, 282.8. centimeters squared. Next, let's look at circles. Find the area and circumference of a circle with radius 3.6 meters. So for a diagram, there's a circle. It has a radius, if I draw a straight line, 3.6 meters. Okay, the area is pi r squared, which is pi multiplied by 3.6 meters and squared. Notice I put brackets around that because my square must happen to the number and the unit. All right. Once I square the number and I square the unit, I will not need the brackets anymore. So let's take a look at what that looks like. I'm just going to leave the pi in front for now. 3.6 squared. So 3.6, and to square that with your calculator, you're looking for the square key and hit equals. 12.96, all right, so that's multiplied by 12.96 meters squared. Now I don't need, the only reason I put the brackets there is because I'm multiplying by pi, all right? So go to the calculator now, multiply 12.96 by pi. Look for pi on your calculator. On this calculator, it has its own button. On some, it is the second function of the 3 or a different second function, so take a look for pi. All right. This calculator gives it in terms of pi, so I just use the change button to go to decimal. And we're going to call this 40.7. So the area is 40.7 meters squared. The circumference is 2 pi r, which is 2 times pi times 3.6 meters. If you like, you can multiply the 2 by the 3.6. That gets you 7.2 meters times pi. All right, with the calculator now. 2 times 3.6 times pi equals, change it to decimal, 22.6 meters. That's linear, not area. In this next one, I'm going to ask you to pause the video and think about how you would find the area of just the shaded area in green. So the ring. And you're given an inside diameter and an outside diameter. Remember, those are diameters. And so pause the video, see if you can find the area of the shaded area in green. When you're back, I'll be taking it up. So the area will be equal to the outer area, which is pi r1 squared, or r outer squared, maybe we'll call it that, minus pi r inner squared. Now we need the radius of the outer and the inner. The diameter was given 6.4, so the radius is half, 3.2 centimeters. Same with here. The outer diameter is 7.2, so the radius is 3.6 centimeters. All right, so the area will be pi times 3.6 centimeters squared minus pi times 3.2 centimeters squared. Now, one of the things you can do, and I'm going to do it over here on the left-hand side, is there's a common factor of pi. So we can factor the pi out. And then I just have to do 3.6 centimeters squared minus 3.2 centimeters squared. That way I don't have to multiply by pi yet, because if we stick with it this way, I'm going to be squaring, multiplying by pi. I'll get a decimal value that I'll have to carry decimal places. So the most accurate will be to do the squaring first. So let's do 3.6 squared. And we saw that before is 12.96. So we have 12.96 centimeters squared minus, and the other one is 3.2 squared. That is 10.24 centimeters squared. So let's do that subtraction. Okay, 12.96 minus 10.24, 2.72. 2.72 centimeters squared. And now I can multiply that by pi. And go to the calculator. Times pi equals 8.5 centimeters squared. Okay, now we could have just completed each of these values here, which would be pi times 12.96 minus pi times 10.24. We would get decimal values for each, right? Pi times 12.96, 40.7 minus, and clear it again, pi times 10.24, which is 32 point, let's call this 32.2. And when we do the subtraction, 8.5 centimeters squared. All right. So two different roots, factoring, since the pi is a factor in each, it can be factored out and brought back in later. Okay, one more feature of a circle is that the angle formed at the center of a circle and bound by two radii, which are here and here, is called a central angle. That's this angle in here. And it forms an arc from its endpoints, all right? So the endpoints of the angle, and it forms an arc. And this arc is a portion of the circumference. And if you know the angle, the central angle in degrees, then you are able to, and the radius, then you're able to find the length of the arc, which is the portion of the circumference. If we think of this as being in degrees, and the one I drew looks like 90, doesn't it? So this is 90 degrees. And that means 90 of the full 360, right? Then the arc in degrees is equal to that. It is 90 degrees of the full 360. And in terms of a fraction, 90 of 360, that reduces to 1/4. Oh, if we look at the portion of the arc that I have in red there, and let me just erase this green so you can see it better. All right, if I look at the portion of the arc in red, it is actually 1/4 of the circumference, because over here would be half, and there are 3 more quarters, right, for 90 degrees. So this even works for any degree. If this was an 89 degree angle, it'd be 89 3/60ths, not as nice a fraction to reduce, but it still is that portion of the circumference. And so if you know the circumference, say for example, the circumference was, okay, so example, circumference equals 100 centimeters. Then the arc length equals 1/4 of 100 centimeters, which is 25 centimeters. Okay, so you can use the central angle as a portion of 360 to find the arc length when you know the full circumference, which you would, if you have the radius, you can calculate it. Okay, so there's a formula. The measure of the central angle is equal to the measure of the arc in degrees. And therefore the arc length is equal to the central angle, degrees, divided by 360, giving you a fraction of the circumference, or a fraction times circumference. And that's my video for this unit on area and perimeter. Thanks for watching.